Welcome to the Explainer. So, you know that loops are basically the engine of your C programs, right? But sometimes you need to grab the steering wheel. Today, we're going to master the C statements that let you tell your loops exactly when to stop, when to skip a beat, and how to run with absolute precision.
Okay, here's the game plan. We'll start with the core problem, the loop's dilemma. Then we'll meet our tools, see them in the wild, and navigate some common traps. After that, we'll solve the mystery of the comma operator, and finally wrap things up by weighing control against clarity.
You know, loops are the absolute workhorses of C. I mean, they're designed to do one thing really well. Repeat a block of code over and over until some condition is met. But what happens when you need a little more finesse than just letting it run its course from start to finish? This right here is the central question we're tackling today. How do you handle those special cases? You know, the situations that require you to alter the loop's natural flow. You can't just let it keep chugging along if you've already found what you're looking for, or if you run into some bad data. So let's get to it. Let's meet the two main tools that C gives us for this kind of fine-grained control, the break and continue statements. The best way to think of them? They're your loop's emergency exit and its skip button. The difference between these two is simple, but it is so powerful. Break is like pulling the emergency brake. It gets you out of the loop completely, right then and there. Continue, on the other hand, is more like hitting the skip track button on your music player. It doesn't stop the whole playlist, it just jumps to the next song. Okay, let's get a little more technical. The key word for break is immediate. The second your program hits that statement, the loop is done. Finished. No more checks, no more code inside the loop will run. Execution literally teleports to the very next line of code after the loop block. It's all about efficiency. Now, continue, it's a different beast. It doesn't end the loop, it just ends the current lap. Think of it like you're telling the program, hey, this one specific thing isn't what I'm looking for, so just skip the rest of the work for it and move on to the next one. It just zips right back to the top for the next cycle. All right, theory is great, but let's see where these tools actually become essential out in the wild. And these aren't just for, convenience. They're for writing code that's both efficient and robust. Just imagine you're searching for one specific number in an array that has 1 million items. You find it at, let's say, index 50. Is there any reason at all to check the other 999,950 items? Of course not. That's where you use break to get out of the loop immediately, saving a massive amount of processing time. Or picture this, you're calculating the average of a list of student scores, but some of the data is just bad. Maybe a score is listed as -1. You don't want that to crash the whole calculation, right? So you use continue. It lets you gracefully ignore that one invalid entry and just move on to the next valid piece of data. Now, this is a really cool and classic pattern. Ever wonder how programs run continuously, like a command menu just waiting for you to type something? Well, a lot of the time, it's done by creating a deliberate infinite loop with while one, and then you put a conditional break inside that only runs when the user decides to quit. Of course, like any powerful tool, break and continue come with their own set of common programming errors. And it's really crucial to know about these traps because they can cause bugs that are a real headache to track down. The most notorious danger of all is the infinite loop. As this quote spells out, if your loop's exit condition never becomes false, your program gets trapped. It'll just spin forever, eating up your CPU until it either freezes the whole system or just crashes. So here's a textbook example of that trap. The code checks if count is greater than 0, and it is, but look closely at what's missing inside the loop. There's nothing there that changes the value of count. It starts at 10, and it stays at 10 forever. The condition will always be true. The hamster never gets off the wheel. The fix, really, is always the same idea. Something inside the loop has to be working towards that exit condition. Here, just by subtracting 1 from count with each pass, we guarantee that it will eventually hit 0. The condition becomes false, and our program can finally escape. All right, let's shift gears from the essentials to something a bit more advanced, and frankly, a bit controversial in the programming world, the comma operator. You know, a lot of programmers, even ones with years of experience, find this thing pretty confusing at first. This user on Reddit just perfectly captured that initial, wait, what moment that so many people have when they first see it in action. So here's the secret. The comma operator does two things, but it only cares about the answer from the second one. It runs the code on the left, throws the result in the trash, then it runs the code on the right and keeps that answer. The entire point is to take advantage of the side effect of that first operation.
Let's just walk through this. If I starts at 0, first I++ runs. We don't care about its return value, but we definitely care about its side effect. I is now 1. Then the second part runs, I + 6. And since I is now 1, that's 1 + 6, which is 7. So x gets the value 7.
So where would you actually use this thing? Well, its most common and most accepted use is to pack multiple actions into a for loop. Like here, for example. We can initialize A and B at the same time, and then in each step, we can increment A and decrement B, all tucked neatly inside the for loop structure. Okay, so we've got all these tools in our belt, but being a good programmer isn't just about knowing what the tools do. It's about knowing when to use them. So let's zoom out and talk about the big picture here. You got to remember that C gives us different kinds of loops for different jobs. While and for loops are entry controlled. That just means they check the condition before the first run, which means they might run 0 times. The do-while loop, though, is exit controlled. It checks the condition after a run, which guarantees it will always execute at least once. So it all comes down to this. All of these advanced control statements, break, continue, and especially the comma operator, they force a fundamental trade-off. They give you this precise low-level control over your code, but that power can absolutely come at the cost of clarity, making the code harder for other people, or even you, in 6 months to understand. And that leaves us with a final thought to chew on as you go out and write your own programs. Just because you can do something in a really clever way, does that mean you should? When is that extra control worth the potential cost in readability? That, right there, is the question every master craftsman has to answer for themselves.